Hello, everyone. My name is Sina, and I'm one of the tutors at Math Zone at the University of New Haven. And today I'm going to be going over factoring by the greatest common factor, or GCF, and also factoring by grouping. Uh, Here we have three learning objectives. The first one is understand and identify the greatest common factor or GCF. And then the second one is apply the GCF to factor polynomials. So first we understand what is actually GCF and how to find it. And then we try to apply that concept into factoring the polynomials. And the third objective is factor polynomials by grouping. So definitions, greatest common factor, or in the short form, GCF, is the largest common factor that divides two or more terms. For example, the GCF of 12x and 18 is 6. So first of all, we have to identify the GCF, or the greatest common factor, between two terms. So between 12x and 18x, we have the factor 6 that is common between these two terms, because if we rewrite 12x as 6 times 2 times x, and we rewrite 18 as 6 times 3, we can identify that 6 is common between these two factors. Notice that we can rewrite 12x and 18 in different forms, such as we can rewrite 12 as 4 times 3, or 4 times 3, or 6 times 2, which we went over. And also we can rewrite 18 as 9 times 2. So if we rewrite 12 as 6 times 2 and 18 as 9 times 2, the common factor between them is 2. But notice that 2 is not the greatest common factor. It's just a normal factor. But in the greatest common factor, as it is obvious from the name, we're looking for the greatest common factor, the highest common factor. Another point is that we can have common factors between numbers, and we can have common factor between variables, which we will be going over in the example in the next slides. But here we had 12x and 18, but 18 didn't have any variables, so we didn't look at the common variable between 12x and 18. But 12x definitely had variables. But since 18 didn't have any variable, we didn't go over the common variable within these two terms. The second definition is factoring by grouping, which says splitting terms into groups to factors. For example, factor 3x squared plus 6x plus 2x plus 4. We split this two term as 3x plus 2 and x plus 2. So these definitions might not be very clear right now, but we will be going over in examples, and in that case, these definitely will make sense. In the next slide, I've arranged some steps in order to factor by GCF. So the first step is identify the GCF of all terms in the polynomial. As I mentioned, two terms may have different factors. We can rewrite two terms as different factors, but we have to identify the greatest common factor between those two terms, and rewrite those two terms in as a factor of that greatest common factor. We'll be going over the example. The step two is rewrite each term as a product of the GCF and its remaining factor. Step 3 is factor out the GCF from the polynomial, and step 4 is write the expressions as the GCF multiplied by the simplified terms in parentheses. Step 5 is check by distributing to ensure the original expression is correct. So first, I will be going over the example of how to factor by GCF, and then we will be going over the steps of factoring by grouping. So here's an example that we're going to solve by factoring by the GCF. So here we have 4x cubed minus 8x squared plus 12x. So by looking at the numbers and variables, we have to identify the greatest common factor. We can rewrite them as a form of 4. So 4x cubed is 4 times x times x times x, 8x squared. We don't need to focus on the sign. We write 8x squared as 4 times 2 times x, and 12x as 4 times 3 times x. Now we're going to identify the common factors, the number that is common factor between these two terms, which is 4, and then we're going to identify the variable that is common between these three terms, which is x. And then the third step, we're going to factor out the greatest common factor, which is 4x. We can say, okay, how can we get from 4x to 4x cubed? By multiplying the term by multiplying 4x by x squared. Or we could say, from these term, we took out 4x, and we're left with x squared. Now, if we take out 4x from this term, we're left with 2x, and then we put the sign, which is negative, so negative 2x. Or we could say, how can we get from 4x to 8x squared? And if we take out 4x from 4 times 3 times x, we're left with 3, and the sign is positive. And now we just solve this question, we just factor this polynomial by factoring by the greatest common factor. And now we're going to be going over factoring by grouping. So how to factor by grouping? The first step is group terms in pairs that have common factors. So first of all, we have to identify which two terms in that polynomials have common factor. And then step 2 is factor out the GCF from each group. Notice that we are using what we just learned, which is factoring by GCF in factoring by grouping. The step 3 is look for a common binomial factor between the two groups. So first of all, we group terms in pairs that have common factor. We factor out the GCF, and then we look for a common binomial. And the third step is factoring out a binomial between the two groups. Step 4 is factor out the common binomial, and step 5 is write the final factor form as a product of two binomials. So here's an example that we're going to be going over. Here we have a polynomial x cubed minus 2x squared plus 5x minus 10. I'm sorry. So what we do is first, as we went over in the steps, we try to group the terms that have common factors, which here are x cubed minus 2x squared and 5x minus 10. If we rewrite x squared, we get x times x times x. If we rewrite 2x squared as their factors, we get 2 times x times x. If we rewrite 5x, we get 5 times x, and 10 is 5 times 2. Now we factor out the greatest common factor in each parenthesis. In terms of x squared minus 2x squared, we have x squared, and in terms of 5x minus 10, we have 5. And then we factor out x squared, we get, so if we take out x squared from this term, we're left with x. We put the sign, and if we factor out x squared from this term, we have 2, and then we put the sign. Plus, if we factor out 5 from this term, we have x only, and if we factor out 5 from 5 times 2, we have 2, and then we put the sign. Now we are in the third step that we have to factor out a binomial, a common binomial from these two expressions, which is in this term, x minus 2, which is obvious, that is common between these two terms. And if we factor out x minus 2, we're left with x squared. So we put a parentheses, it's x squared. I'm sorry, I don't know what just happened. So we were here, yeah. So if we factor out x squared, we are left with, no, we went over this. Now here, we're going to factor out a common binomial, which in this term, which is in this question, is x minus 2. And then we're going to factor out x minus 2 from each of these two terms. And if we factor out x times x minus 2 from this term, we're left with x squared, which we have the sign plus, and 5. Now we have factored out this polynomial by factoring by grouping. Thanks for watching.